Okay, so the problem states that the distance between two telephone poles is 50 meters. And when a 1 kilogram bird lands on the telephone wire midway between the poles, the wire sags 0.2 meters. It asks you to draw a free body diagram of the bird, and then it asks how much tension does the bird produce in the wire. Ignore the weight of the wire. Okay, so this is my incredibly artistic diagram. These are the two poles and 50 meters across, and the bird is exactly in the middle. We'll pretend like that's exactly the middle. So it's 25 meters this way and 25 meters this way. You notice I've defined the positive x direction as the right and the positive y direction is straight up. So here's the bird sitting on the wire, and we know that its weight is going to be mass times gravity, and we know that it has a mass of 1 kilogram, so we multiply that by 9.8 meters per second to get a weight of 9.8 newtons. So in my free body diagram, I will draw 9.8 newtons going down. And the thing that is holding the bird up is the tension in the rope on each side. So T1 is pulling him up that way at an angle, and T2 is pulling him up that way at an angle. And that's what's balancing out the 9.8 newtons and holding him stationary, because we know that the sum of the forces is going to be 0 because he's not moving anywhere, so there's no acceleration. The other thing we know is that T1 and T2 are going to be the same, because if he's right in the middle of both of the wires, we know that the force that each of them has on him is going to be equivalent. So with that information, we go over here. We're trying to find the angle theta between, it's going to be this angle right here, between the bird and the 25 meters he is from the pole and the 0.2 meters of sag that is in the wire. So theta is going to be, tangent theta is going to be 0.2 meters over 25 meters. So we solve that and we get theta is equal to 0.458 degrees. So it's not a lot. Now we go in here and we say that the sum of forces in the y, as I said earlier, we know that F equals ma, and we also know that there's no acceleration, which means that the sum of the forces in the y direction is 0. So we think of all the forces that are going up. As we said, y is defined as, positive y is defined as up. So the forces that are pulling him up is going to be this component of the y component of the tension, which is T1 sine theta, and the y component of this tension, which is T2 sine theta. And then that's all the forces going up, and we know the force going down is going to be minus mg, because the weight is what's pulling it down. And we know this is equal to 0. So we can move mg onto the other side and factor out T1 and T2, and so we know that T1 plus T2 is going to be 9.8 newtons divided by sine 0.458. And like I said earlier, we also know that T1 is equal to T2 because the bird is exactly in the middle of the two poles. So once we substitute T1 in for T2, we get 2T is equal to 1,226 newtons divided by 2, and we get that the tension in the rope is 613 newtons, which is your answer.